Well, hello and welcome to a new unit in math class. Today we're going to identify congruent and similar polygons. Don't panic, I know the words sound a little mysterious, but don't worry, it's really not hard at all. And while we're doing that, we're going to find missing side or angle measurements of congruent figures. Wow. Okay. So, what do those big words mean? Well, they're not really that big, but congruent. You guys know what similar means, and polygons are just shapes with many sides. That's what polygon means. It means many sides. So let's talk about congruent or similar. Similar means they're just the same shape, but one can be smaller than the other, or bigger than the other, depending on which way you're looking at them. Congruent means they have to be the same size, and the sides and angles have to be exactly the same. Okay? So for congruent, they match exactly the same size. Okay? But for similar, they just match in shape, but they don't have to match in size. So, what does those two words have in common? Well, right there in the middle of the diagram you can see they can both be rotated, but their angles will always be the same, and of course they're the same shape. So when we're talking about two congruent triangles, they're both triangles. We're not going to compare a triangle to a square, or a hexagon to a, I don't know, what's another one? A heptagon or a triangle or circle. We're not going to compare two different shapes. So that's what we're talking about. Shapes that are the same shapes, but how do they compare? Are they similar, meaning they're different sizes, or are they congruent? That's the important thing we want you to get today. So when you think of congruent, think about making cookies. Yay! And you can see Valentine's Day is coming in a few weeks. But think of congruent as having a cookie cutter and cutting out all exactly the same size. So you can see there's all those wonderful cookies there. The ones on the left are a little larger than the ones on the right, but the ones that are on the left in that row, or that column, they're all the same size, so they're congruent. The ones on the right are all congruent with each other. But if you compare left to right, so say that top one there that says love on it, and the top one out next to it, which has all those little pretty hearts, those are just similar because they have the same shape, but they're not the same size. Easy stuff, right? So, one more time, congruent polygons, meaning many shapes, have the same size and shape. So if you put one on top of the other, they're going to match up perfectly. So think about cookie cutters, or more like copying and pasting. And let's see if our two, what is that, pentagons, are matching up perfectly. Oh, looky there, they do. Isn't that special? Okay, so here's some more information about congruent polygons. The parts that match up are called corresponding parts. Ooh, corresponding, another word. We're going to have to make a list of these words, aren't we? Okay, so the parts that match up are corresponding. So what do we mean here? We've got two congruent triangles here. And as you can see, they're not facing the same direction, so you might be a little bit not sure if they're actually congruent. But as you can see in the box in the middle where it says triangle ABC, and it's got that funny squiggly and an equals, that means congruent. Equals means they're equal, and the squiggly, I think it means they're similar too. Okay, so similar and congruent, they are. If you have two congruent things, they are also similar. Oh, well, anyway, so they're equal to triangle TUV. Now, there's something really important about the order on this triangle, those letters. Okay, so if you look at triangle ABC, the A corresponds with the T in the other triangle. See what I'm saying? And the B corresponds with the U in the other triangle. Here. So this A right here corresponds with this T right here. They are the same size. Okay? They match up. And if we rotated this around and put it on top of that one like I just did the pentagon a minute ago, that would be, you would see they would match up exactly. All right. So when you write a congruence statement, that's what this is called right here. Congruence statement. Okay. We're going to keep the corners or the vertices, we're going to keep them in the same order so we know which ones match up. That's how we can tell for sure. Okay. So here's another little trick we can do. These are called tick marks. And sometimes they're spelled like that. Sometimes they're just spelled T-I-C. Okay. So I don't know which one's which, but you can use the tick marks to figure out which parts are congruent. So here we have, first of all, this is an example of the letters by saying the letters in a certain order. All right, so W, E, T, D, that polygon right here is congruent with N, A, C, D, which is over here. Now, they come together. They share D, but that's no big deal. It just happens they do. So W corresponds with the N. So the W right here, this angle W, corresponds with this angle N, is congruent with. And notice these tick marks. There's one little tick mark here and one little tick mark here. So if we didn't have this, we would know that these two are congruent because they're all in the same drawing and they have the same number of tick marks. So you can see T over here, it's a different measurement, and let's look on the other one. T is congruent with which one? The C. And notice the T is the third one in the order, C is the third one here. Okay, so the sides are the same thing. Take a look at these sides. We have the side between W and D, or DW, or WD, DW, I don't know, whichever way you want to say it. But anyway, this side is congruent with this side. So CD and WD are congruent. Notice the tick marks match. Easy stuff, huh? Let me show you. You don't always have to have the letters in the same order as this. There isn't a one only way. Usually we go alphabetically and neither one of these do, but it doesn't matter. But notice when I rearrange the letters on this one, T, E, W, D, they still match which ones they were congruent to. If you notice, T is still congruent with C, and our T and our C are still congruent. Our E, our W, that was one we talked about. W and N. W and N are still congruent. So you keep them in the same order. So you could have 4 different ways of doing this. Well, actually, more than that. I don't even know. I can't think. Maybe 16? I'd have to figure it out. That's a different unit. So let's just go on with lots of ways you can answer that question if I said what to match up the corresponding parts in our congruency statement here. Okay? But that would be correct. So let's go on. So, number 1 for you. Are these two congruent? Okay, so we're also talking about similar polygons, and I'm going to have to move myself. I don't know, no matter where I put myself, you're missing something, so I'm going to leave myself right there. Similar polygons have the same shape, but they're not necessarily the same size. Okay, congruent can be similar, but one polygon can be an enlargement or a reduction of the other. So you can see this one, that you can see most of it. All right, DEF is larger than ABC. All right, they are similar. All the corresponding angles are congruent. So right here, this is the similarity congruency statement right here. Angle A is congruent with angle D. And so let's see. We've got angle A right here, angle D right here. Okay, they are congruent. They are the same size. So if I told you what the size of A was, you could then tell me what the size of D was by just repeating what I said about A. Simple, right? All right, so this is what we were getting to. The symbol here, this little thing, shows that they're similar. So back on the other page when we saw the equals with the little tilde, we call that, they are congruent and similar. Okay, so even though these are just similar triangles, their angles are congruent. Whew, lots of good information. So tell me, are these similar or not? All right, I got a couple more for you, but before I let you do numbers 3 and 4, I got to help you out with, I'll help you out with these two. So we've got the measure of angle E, all right, it says here that the corresponding angles are congruent, the corresponding sides are congruent, and down here is our congruency statement. ABC is congruent and similar to EFGH. So when they're congruent, that means the angles are congruent and the sides are congruent. So first of all, this one's asking for the measure of angle E. So let's look. Angle E. Oh, it's over here. Sorry, I covered that up a little. There we go. Angle E right here. All right, so what is angle E corresponding? Let's look in our little statement here. Let's see, E is the first one, A is the first. So it's A. Oh, cool. All right. So I don't have my pen working. Let me get my pen. Here we go. We can write it right in here. Our E corresponds with A, and A's measurement, I'm using the wrong end of the pen, it usually helps to use the pointy side, is 79 degrees. Simple. All right. So for you, number 3, you're going to do the measure of angle H. Figure it out. Put it in there on your answer. All right. Now that you've done that, I'm so sure you got it right. Well, let's take a look at this one. This is asking for, in millimeters. So it's asking for the length of FG. So let's take a look. What are we looking at? FG. All right, that's the side we're looking at here. So it's between, let's see, F is the second letter and G is the third letter. So it's looking for between B and C. See how we're doing that? Between F and G, B and C. So let's look here. We got B here. Oops. My pen doesn't want to work in that spot on my board. B here and C here. So we're looking for that one right there. 4.1 millimeters. Okay, now it's your turn. You find HG. Well, I hope that was helpful and not too painful. And I move myself out of the way again. Here's just a little summary of what a congruent polygon looks like. Here's what the statement will look like for these, comparing these two. All right, notice again, WALP, WALP, is congruent with DTNS, and I will know how to say that. So therefore, all of their angles are congruent. All of their sides, when you compare them, are congruent, exactly the same size. Now we've got over here, we got these two polygons, and WALP, we got WALP back, but we got a new one comparing it, and it's a little smaller looking. So therefore, only its angles are the same. Only its angles are the same, not its sides. Like over here, it said the sides are the same. They're not. Now, if we know what the measures of the angles of, or what do we call it here, BFME, could we tell you what the angle measures are of TDNS? Oh, now that really makes the brain explode. Well, of course we can, because this one is similar to this one. The angles are the same. Well, this one is this one over here in this comparison, so the angles are the same. And then we could figure it out. We totally could figure it out. So logical. Too early for brain explosions like that, right? Well, I'm glad you could watch. I hope you understood this. Have a great day and do a good job on your practice work.